Stoichiometry notes, example number 11, second year chemistry, Chem 2. In a reaction, 78.0 grams of iron chloride reacts with 56.89 grams of sulfuric acid. Suppose the percentage yield is 93.76%. How many grams of iron 4 sulfate are formed? Okay, remember that every problem must start with a mass, a volume, or a mole, and a half percent yield. But before we can even begin, we should probably write a balanced chemical equation. Take a moment, please, to write a balanced chemical equation on your notebook paper or your whiteboards if we're in class. Welcome back. Here is the balanced chemical equation for the reaction in number 11. Hello, I took the time to go ahead and calculate, or we would have done this as a class, the molar masses of all the different parts of this balanced equation. So the 197, the orange numbers, represent the molar mass of the one above. Okay, remember that every problem must start with a limiting reactant, and every problem must start with a mass, volume, or mole. We have two masses and a percent. Whenever we have a percent, we have to consider whether it's a percent yield or part over whole percent. In this case, I see the word percent yield, so I know I'm going to have to consider at some point A over T equals percent. In this case, we're going to make this equal to 0.9376. We need to figure out A over T. We'll be given, or be able to get one of these. We don't have an experimental amount given, but we can get the T. How can we get a T? We can start with the limiting reactant and use Stoke to go with it to get our T, because I have given amounts. So we're going to start with the two givens, the 7880 grams and the 5689 grams, and go to the same point of comparison to figure out a limiting reactant, because one of these is the limiting reactant and gives a true answer, and one is the excess reactant and gives a lie, a false answer. So we're going to take both of them to iron sulfate. Remember, we can take either of the reactants to the same comparison point, so we might as well take them both to iron sulfate, because we're going to have to answer something about iron sulfate. Okay, so we're going to take the 7880 and the 5689 and go to iron 4 sulfate. So first thing I'm going to take is the 7880. Got to get rid of grams, use the periodic table number. The fact that I know 197.65 grams of iron chloride equals 1 mole. Then I'm going to mole shuffle. Where we're going goes on top. Remember, we're going to iron sulfate. And in my balanced equation, they're 1 to 1. And then I'm going to use the periodic table number to get from moles of iron sulfate to mass. And I get 87 grams of iron sulfate. There you go. So that's one possible answer. So I don't know if this is a limiting reactant yet. It produced 98. We got to see what the 5689 grams will produce. Okay, so that being said, we're going to start with 5689 grams of sulfuric acid. We're going to use the periodic table to get from grams to moles. Then we're going to mole shuffle. Okay, let's look back at our balanced equation. 1 to 2 is what we should have gotten. Yes, we have 2 of these, and we have 1 iron chloride. Excuse me, 2 of these, and we're going to iron sulfate. So we have 2 sulfuric acids and 1 iron sulfate. So that's why we get the 1 to 2. We use the periodic table number to go from iron sulfate to iron sulfate grams, so 1 mole to grams, and we get 71.98. So this guy is the big fat liar, and this is the limiting. So this is the limiting reactant. This is the excess reactant. And the limiting reactant gives me the correct amount, theoretical amount, because the limiting reactant must produce the theoretical. The excess reactant cannot produce the theoretical. How do I know that H2SO4 is a limiting reactant? When I take both of them to the same comparison point, the one that produces the least amount of the same comparison point is my limiting reactant. Since iron chloride produced 98 and sulfuric acid produced 71, we know that sulfuric acid is my limiting reactant. It also gives me my theoretical yield, because remember, a theoretical yield must come from a limiting reactant. So we can take the 71.98 and put it up here where our T is. So we're going to put this into 71.98. Let me make sure I have memorized that correctly. 91, sorry, 71.91. 71.91. We're going to put this over 1. We're going to cross multiply. So that's going to be A equals whatever on my calculator, 71.91 times 0.9376, and we get times 100. Excuse me, not times 100, I apologize. Let me try that again. We don't need to multiply by 100 because we already have a percent, so we're going to take one more time, 71.91, cross multiply, times 0.9376, and we get 64. We get 64.42 grams. Now, let's talk about A over T because we need to emphasize this. This all must be the same stuff. What was the 7191 of? Well, remember, it was of iron sulfate. And so was our percentage. Okay? Because we yielded 9376. Okay, so we have to assume, since we have no idea about the iron hydrochloric acid, that this is still talking about. Remember, A over T must be iron sulfate, must be iron sulfate, if this percentage is of iron sulfate. So that's how I cross multiply, and this would be your final answer. That concludes example 11. This is a clean version of the problem, giving us the answer here. The only thing I added here was putting in the 1 in so we could cross multiply. So this is where we took both of the answers to the same comparison point, got our limiting reactant established as sulfuric acid, which give us 71, the smallest amount of same product. Put that up here in the T, because remember T is the value with the limit, starting with the limiting reactant. So stoichiometry, starting with the limiting reactant. When we cross multiply, we get the 62.42 grams.